Welcome back, everybody, to this Rule of Derivatives Part 5 video. So today we're going to look at a new rule, but before going into that, I wanted to take a quick look at what we have done already. So to save some time, I have actually put them on the whiteboard already. You don't really need to copy this. It's already in your notes if you've been watching rules of video 3 and 4. But it's going to be nice to have them before our eyes for the rest of what is to follow. So I got me 10 rules. And in the last video, the two new rules that we added were rules 9 and 10. So the derivative of sine is cos, and the derivative of cos is negative sine. The other rules were obtained in previous videos. Good. So just to have this before our eyes, we're going to make a little bit of a division of the very small whiteboard over here. And we're going to get into the topic of the day. And the topic of the day is a word you're going to hear often between now and the rest of this course. It's called chain rule. Chain rule has actually several versions. We're going to take a look today at one of them, called the power rule. So one of the version of chain rule is called the power rule for a function, and that is the one that I would like to investigate with you guys. Okay, all right, so before we do anything here, a little intro. I would like us to do a little bit of algebra before we can actually figure out what this chain rule, power rule for a function is about. So consider, well, we're going to be starting with a little bit of algebra. Consider f of x is equal to 5x plus 2 to the power of 3. Haha. Some of you are clever. You've noticed that this is called a power rule, and I have a function here with a power. Of course, they're related, guaranteed. But in the meantime, if I wanted to find f prime for this, what is f prime of x for this function? I would have very little option, wouldn't I? The only option that I have is to expand 5x plus 2 to the 3 and then use whatever rule that I already have to figure it out. So unfortunately, that's what we're going to have to do. So f of x is, all right, 5x plus 2 to the power of 3. What is that? It is, of course, 5x plus 2 times 5x plus 2 times 5x plus 2, right, to the power of 3. Notice that I'm not dealing with f prime quite yet. I'm just trying to figure out another way to get f of x. Okay, what is that? We're going to do the first two, and then we're going to do the other one. Qu'est-ce que c'est? All right, 5x times 5x, 25x squared, plus 5 times 2, 10, and another 10, that'll be 20, and 2 times 2 will be 4. Okay, so basically, that was pretty easy. Elementary algebra, elementary FOIL. Now, to go into here, I am going to skip a few steps and basically just go straight to the answer, which is going to be something like 125x3. What else are we going to get here? 120 plus 50, so that's 150x squared. In terms of the x's themselves, I'm going to have 20 and 40. I'm going to have 60x, and 4 times 2 is just 8. You don't have to take my word for this. If you don't believe me, you can actually do the FOIL, you know, blah, blah, blah. and do them one by one and collect your like terms. It's just algebra, nothing scary here. But what I have here is a sum, a bunch of terms that is a sum. So it should not be exceedingly difficult to find f prime. So this is f. Now to find f prime is this. I need to prime this guy. So to prime this guy, I need to prime 125x3 plus 150x2 plus 60x plus 8. I need to prime this. How are we going to do that? Well, this is where we can actually look at the rules we have on the whiteboard and decide which one applies. They're all separated by a plus sign, so rule number 6 is the rule that has a plus sign between functions. So I'm going to tag along the prime to each one. Well, that's 125x3 all prime. That's 150x squared prime. That is 60x all prime and 8 prime. All right, how would you do this? How would you do the derivative of 125x3? And be ready to justify your answer by the use of one of the rules. 125x3 is a constant times a function. Rule 5, a constant times a function. Take the constant out, derive the function. Take the constant out, derive the function. Hey, same thing. Take the constant out, derive the function. Again, 3 times the same rule. Take the constant out, derive the function. And finally, the 8, the derivative of a constant is just 0. So what is this? That's 125 times. What rule do I have for the derivative of x3? Rule 4. X to the 3, bring the 3 in front. 3 minus 1. We're looking at 3x squared. Same rule for x squared. X squared, bring the 2 in front. 2 minus 1, 2x. Plus 60 times the derivative of x. That's rule number 2. The derivative of x is 1. So here we go. We have this expression that corresponds to the derivative of f. Good. All right. I am going to multiply the 125 and the 3 and everything on the next whiteboard. Right? So do I need this? Oh, I might actually need this again. So let's keep it. So here's what I will erase. I will erase everything but what is in green. Okay, vamos. I'll get rid of this as well. I know it. Okay. So what do we have for f prime? Let's do it over here. We had 125 times 3, so that would be what? 375 x to the power of 3. What else do I have? Of 2, sorry. No, of 3. Plus 150, that's the power of 2. Plus, what do we have after that? I believe we had 60 plus 40, that was 60x. No, actually, I got that wrong. I have gotten that wrong. This is 375x squared. Yes. Sorry about that. 375x squared. And that's 300x. And that would be 60. That's my f prime. And that's a pretty bad square. I think I can do better than that. It's a square on steroids. All right. So that's f prime. 375x squared plus 300x plus 60. Okay, big numbers. Anything perhaps that we can factor out of this? It so happens that 15 goes evenly into 60, and 15 goes into here, and 15 goes into there. So you know what? I'm going to factor out 15 from this. 15 goes into 375 25 times. 15 goes into 320 times. 15 goes into 60 4 times. And here we are, 25x squared plus 20x plus 4. Ha! I don't know, that rings a bell. In the previous whiteboard, didn't we have that exactly when we multiplied 5x plus 2 times 5x plus 2? If you notice that, good for you. That is indeed 5x plus 2 times 5x plus 2. So that's 5x plus 2 squared, I guess. That's 5x plus 2 all squared. We did that like in the previous whiteboard. Yep. Well, let me see. I would like to write this differently. Okay, so just these are going to be a couple of kind of like, what is the teacher doing? Okay, trust me, for a couple of steps, you're going to see where I'm going before the end of this whiteboard, I promise. Just bear with me. So I'm going to have here 3 times 5. That's 15, all right. Right? Nobody can argue against that. 3 times 5, 5 times 3. That is 15. But here's what I'd like to do, and this is where it gets fun. So 3 times 5x plus 2 times 5. I basically take the 5 that I have here and I move it after. It doesn't change anything. Multiplication is commutative. We can move the terms around. And now I'm pulling a quick one on you. Here you go. This is 3 times, I forgot my square here. Sorry, my bad. I'm careless. So that's 5x plus 2 squared. And I'm going to multiply this by 5. But it's going to be a special 5. It's going to be, well, if you saw this, you're very clever. Here's 5. I wrote 5. This is 5. Doesn't it look like 5? It is 5. Why is it 5? Because the derivative of 5x plus 2 is the derivative of 5x plus the derivative of 2. Now, the derivative of 2 is 0. What's the derivative of 5x? Rule 3. The derivative of 5x is 5. So that is actually correct. 5 and the derivative of 5x plus 2 are 1 and the same. Well, look at that. Ain't that interesting? Ain't that interesting? 3, 5x plus 2, square, 5x plus 2, prime. Let me just draw a line here. Leave a little bit of space because I got one last thing to write here, but not yet. I want you to just recall where we started with this. We started off a little while back with 5x plus 2 to the power of 3, right? This is what we had. Look at its derivative. Look at its derivative. What is the derivative of 5x plus 2 to the power of 3? Remarkable. The 3 went in front, and we went 3 minus 1. If that doesn't remind you of rule 4, it should. What's rule 4? Bring the n in front, n minus 1. Well, bring the 3 in front and subtract 1. You get 2. But here's the thing. It is followed by 5x plus 2 prime. The same 5x plus 2 that we can actually find in here. In this last statement, we have the power rule for a function. What is it? I'm actually going to write it in a different color. Let us see if we can come up with this rule by ourselves. So f of x is 5x plus 2 to the 3. You want the derivative, the 3 comes in front, and minus 1. So f prime of x should be n, and then the function, whatever it is, goes to the power of n minus 1. And then, if we call this function here f of x, if we call this function here f of x, then what do we get here? We get f of x with a prime. We get f of x with a prime. And this is the remarkable power rule for function. This is the power rule for functions. For, what was that? For functions. Power rule for functions. Right there. So if you have f of x to the power of n, if you have f of x to the power of n, then the derivative will be, bring the power in front, n minus 1 f prime. I'm going to write this here. That's going to be my rule number 11, something to be added to my list. I will recopy this on the top of the whiteboard in my next one, and then I'll do some examples. Good. So getting rid of this, leaving this here for future reference, and we now have rule numéro 11, rule 11. What is that rule 11? If you have f of x that is raised to a power of n, and you want the derivative of this guy, then the result we have obtained is, similarly to rule 4. What's rule 4? Bring the n and subtract 1 from the exponent. Alors, same thing. Bring the n in front, subtract 1 from the power. So n fx to the n minus 1. But it doesn't end there. It has an extra term. And that extra term is the function who is now derived. What is important here, if you're going to be successful in this section, is to remember that what goes in here, in this square bracket, f of x, should be the exact same thing at what goes in there, f of x. This is the key to doing those problems correctly. What is in here and what is in there must always be the same. If you abide by this rule, those chain rule problems are not going to be complicated at all. Bon, all nice. Let's do an example. Call it example 1 for today. So evaluate, let's say, x plus sine x to the power of 4 prime. So we want the derivative of a function called x plus sine x to the power of 4. So what does one notice? One notices that here in the bracket is something called f of x. And right here, that 4 is a power of n. So what we have here, ladies and gents, is just what we have covered. It's an f of x, it's a function raised to the power of 4. It is truly in line with rule 11, f of x to the power of 4. So what's my f of x? It's x plus sine x. And what color am I in? Blue. So here, I'm just going to go aside and just like remind myself that f of x in here is x plus sine x, and I'm going to remind myself of the value of n, which is 4. This is all I need. Now I go into my function, my formula, sorry, and I put it in. So x plus sine x all to the 4 derivative will be, okay, it goes like this. Bring the power in front of the function, subtract 1 from the exponent. So don't touch the x plus sine x, just bring the 4 in front. And subtract 1 from the power. So 4 minus 1. Times, now we need to multiply the function prime. But remember, the function is what's inside the bracket. The function is x plus sine x. This is your function. So what follows here must be the same as what this bracket is, but prime. That's the secret to the power rule. So we go here, and we go x plus sine x prime. Once again, it is very important to notice that what is inside this round bracket and what is inside this other round bracket are one and the same. This is a mistake that we want to avoid. When these two are different, then basically when we have written two different things here, we cannot hope for the correct answer anymore. So here we go, second to last step, 4x plus sine x to the 3. And how would you do this? Well, this is why I left the first 10 rules over there, because we need to look at them to do that. Two functions separated by a plus sign. Two functions separated by a plus sign. It's the plus rule, meaning the first one gets the prime and the second one gets the prime. All right, final answer, 4x plus sine x to the 3 times rule number 2, the derivative of x is 1. Rule number 9, the derivative of sine x is cos x. Box this, walk away. That's your final answer. That is your final answer. Okay, good. So that's a relatively entry-level example. We should do something perhaps a little more involved in the next one. So we'll erase this and we'll do another example here. I guess I want to leave my rule 11 over here. So moving on to example numéro 2. Blue will do. Example 2. Example 2. What shall we have in example 2? Why don't we take something like this? Evaluate something prime, a square root, (6x3 plus 7x squared minus 1). Square root of all this. Okay, quick question. Can I take the square root of x3, 6x3, and the square root of 7x2 and the square root of minus 1 separately? No, right? Because remember that the root of a plus b is not the same as the root of a plus the root of b. So we cannot separate the root when we have pluses and negative. That is not good algebra. Well, what can we do if we can't do that? Well, any suggestions? We're in the section about chain rules, so we expect some sort of a power to pop up someplace. And what better power than the power 1/2 for the square root? So what we really have here, f of x, is 6x3 plus 7x2 minus 1. It is actually the same as the square root as if we put a power of 1/2. Good. So Why don't we call it not f of x, okay? Why don't we call it g of x? Let's just give it another name. You'll see why in a minute. Okay, let's call that g of x. Why? I want to make a comparison between what we have and the formula that we have above here in rule number 11. In rule number 11, we have f of x to the n. We do have f of x to the n here as well, don't we? This is f of x. This is f of x. And this is n. So my f of x in this problem is 6x3 plus 7x2 minus 1, and my n is 1/2. I'm going to write this right here on the side just to make sure that it's very clear for everybody. Here, f of x is 6x3 plus 7x squared minus 1, and n is the fraction 1/2. Good. So what is g prime? What if I derive this? Well, the derivative of f of x to the n is n, right? So 1/2. F of x to the n minus 1. And f of x is just 6x3 plus 7x squared minus 1. Times. To finish the sentence, I need to multiply this by f prime. Again, f is what's inside the bracket. So I just recopy the bracket, and instead of putting an exponent to it, I put a prime. And here we go. 1/2, function 1/2 minus 1, function prime. So we have, this is not finished, 1/2 6x3 plus 7x squared minus 1. What's my power now? 1/2 minus 1, that's minus 1/2. Uh-oh, negative power. We're going to have to deal with this before the problem is over. Times. What rule should I use for this? There's a plus and a minus between functions. There's a plus and a minus between functions. Rule 6. The derivative of a sum is the sum of the derivatives. So I'm going to apply the prime to each one. Prime to 6x3. Then the prime for the 7x2. And then the prime to 1. So what is that? 1/2. Okay, no me gusta. I don't like. Je n'aime pas. The negative exponent is not welcomed in my answer. Get rid of it. 1 over the same thing to the power of 1/2. Positive power downstairs. Notice that the inside of the bracket changes not. The very, very same it stays. Times. How do I derive 6x3? Rule 5. There's a constant in a function. Take the constant out, derive the x3. Take the 7 out, derive the x2. Same rule. And what is the derivative of 1? It's a constant. The derivative is plain 0. Good. So that is 1 over 2 times 1 over 6x3 plus 7x2 minus 1 to the power of now positive 1/2 times, what do we have here? 6 times, what is the derivative of x3? Rule 4. x3 is 3, x to the 3 minus 1, so x2. 7. X to the derivative, again, rule 4. 2x1. And the 0, I really don't need to write. Cool. So, what I have, all in all, is what? What could I do here that would be nice? Well, I could actually write everything perhaps like this. So 18x squared plus 14x, right? This is 6 times 3, 18, 7 times 2, 14, over 2 times 6x3 plus 7x2 minus 1 to the 1/2. That could be a good answer if we don't have to simplify. But if we do have to simplify, do you have a suggestion? Yeah, take a 2 out of the numerator and cancel it with the 2 at the bottom. So 9x squared plus 7x. What did I do here? I took out a 2 from here, and I canceled it with the 2 there. Over 2 to the 1/2 is the same thing as the root. I will accept both. They're both good. So just perhaps to have something different, the root of 6x3 plus 7x2 minus 1. And now we have a slightly simplified answer. Just to mention in passing that if the question had been do simplify, and then I would have to have this answer. That's a do simplify. If the question had been do not simplify and it was not specified, then that would have been an acceptable answer. This is not quite simplified. This is simplified a little more. Okay, so because of the derivation of the formula, we only had time to do 2 examples. So in the next video, I'll do at least another one. And of course, on Zoom, when I see you again, I'll do more. In the meantime, take care and have a good rest of the day. Bye-bye.